Let's start. Last week, most of us were in San Francisco for attending the Sisters meet and then offline face-to-face discussion regarding to the design of SeaStor. I think the gist of the discussion is that most of them are document in the SeaStor plan document, and we will have I will post the takeaway to the safe development mailing list shortly. And aside from it, I started working on the very preliminary design implementation of a Redis tree using SeaStor, and also the early design of an allocator. And I think that's me. And by the way, I will try to wrap up the review of the aerator and Elenite BlueStor in this week. That's the plan. Oh, Chunmei, how's it going?
I'm a little late, so I'm missing some of your sentence. So let's start from me. The Alien BlueStar PR is updated, so please ask you guys to review it. And I have questions about the SeaStor file system. So we discussed the algorithm. Redis tree and B plus tree will be used in our database. So do we need a file system under the database, or we select an existing file system, or we write by our own?
No, we're going to run directly on a block device. That's what the allocator is.
Pardon?
No, we'll be running directly on a block device.
Directly access the block device without the file system.
That's right.
Okay, thank you. Okay, so no more from me. So just wait for the comments.
So the allocator is for memory or the blocks?
Blocks, I
Yes.
believe.
Blocks.
Okay. Blocks device.
Yes, disk.
So essentially, so do you want me to talk a little bit about why we're sort of assuming we don't want a file system? Or no?
I'm good.
Please do.
Okay, the reason is because we went down this path with BlueStor. And the reality is that in order to do a sync in a conventional file system, you need to issue an fsync, which issues a barrier to the disk, right? But if we're actually want to batch up a sequence of operations that we know, because we're smart, are not at this time or don't independently need to be persisted, and then issue a single barrier at the end, for instance, because we need to do writes to several places on a file, update another file, and then sync them all with the same barrier, there is no way to make a file system do that, basically. Mm-hmm. So essentially, Sage spent quite a while trying to make NewStor, spelled NEWSTORE, work that way, where he essentially used XFS as an allocator and ran everything else on top of it, and he could not eliminate the extra barriers. So for that reason, we're essentially borrowing Sage's research from when he was designing BlueStor to assume that there's no way to make XFS or any other file system do what we need it to do. And for the record, we did talk to the file systems community, and they weren't really amenable to adding the interfaces we would need because they would be incredibly easy to misuse. That's the 1-minute version. So essentially, the only parts of an actual file system we'll be re-implementing are the allocator and some logic about how block I/O is dispatched. The rest of it, of an actual file system, we don't need at all. We don't need any of the directory structures. We don't need any atomic updates to said directory structures. We don't need atomic moves across directories, which is quite hard, actually. We don't need any of the security or permissions structures. So by not using a file system, it makes it a lot cheaper. Does that make sense?
Yes. So using allocator, do you mean we need to implement an allocator or reuse an
Precisely. Yeah.
Okay.
Yeah. So we need, at a simple level, a way to say, I want 4 kilobytes of block, right? Please give it to me.
Yeah.
And more importantly, write down what you gave to me, so that in the future we don't reuse it. It's an important element of a file system, but there aren't any file systems that are structured in a way, that I'm aware of at least, that you can simply lift that part out. So we'll have to write our own. Does that make sense?
Yeah.
Very much.
Makes sense.
Cool. It's a little bit controversial because typically you don't want to write directly to a block device. We ended up here after desperation, I guess.
Yeah,
But it also has some nice.
To avoid that has a good summary
So
of why we want to teach file system.
But this approach has also some nice side effects, like like giving possibility to vendors to integrate to use CEF as a kind of testbed. I believe that workarounding that skipping the file system kernel file system dependency enabled CEF to get things like PMM integration, SPDK integration. Without that, it would be impossible.
Yeah, you're right about that. So the ZNS integration that Abudulab was doing for BlueStore would have been a lot more difficult if he had to retrofit all of XFS to support it, right? So we'll have the same advantages when we do the persistent memory stuff. We don't want to sidetrack too far on this. I just thought it might be worth pointing out why.
So we don't use the native file system. Do you mean we also don't need a file system like BlueFS?
So let's be clear. BlueFS is not a full file system.
Yeah.
BlueFS is just an adapter between RocksDB's internal interface. So RocksDB has an interface between itself and a disk that speaks about opening files and writing sequentially to them. So BlueFS is just a stub file system on top that is part of BlueStore that just kind of connects that really simple interface to BlueStore's allocator.
Okay, so because the database is written by ourselves, so we don't use that interface. Right? We don't need that interface, right?
Well, we don't need BlueFS itself because we're not using RocksDB. Truly, RocksDB is just a function of the fact, BlueFS is just a function of the fact that BlueStore uses RocksDB internally.
Yeah, I see. Thank you.
Yeah, it's just an adapter layer.
Yes, that interface was defined by RocksDB. That's why we want a layer to abstract the underlying blocks access, so it can be consumed by RocksDB.
Yep, and it resides in the user space. There is no dependency on kernel. BlueFS is basically a private thing of BlueStore.
And to be clear, it's just a piece of BlueStore code. It's just somewhere in source OS BlueStore. It's just a couple of files. Not a lot to it.
Yeah. Oh. Avnon, by the way, Avnon is a new intern from based in Israel. He joined us like one month ago. Could you do a very quick, short introduction?
Avnon, you're muted if you're trying to speak.
Yeah, sorry, can you repeat the question?
Just introduce yourself.
Okay. Yeah, hold on, I'll turn on the camera as well. Hi, everybody. My name is
Hi.
Amnon. I'm based. Hi, good morning. Right. I am. So my name is Amnon. I am based in Israel. I also work from the Ra'anana offices with Ronen. I am currently a student at the Technion in Haifa. I study software engineering, and I just started my third year. And I joined the team about a month ago or so, month and a half. And yeah, previously I worked at CERN on data acquisition on a new detector called Phaser. And yeah, if you have any questions, feel free to ask me.
Did you have any interaction with the Ceph cluster at CERN?
No, I didn't.
I'm just curious. Cool.
I think Arnon will start with some CPD release tasks and then move on to the performance tuning of Chromosome as a whole. That's that plan.
Welcome, Aman.
Thank you. Yes, Kefo, I saw the email you sent me yesterday.
Redek.
I've sent a couple of things. First of all, I've sent the patches we have for Ceph SeaStor repo to the upstream. I've got reviews from both Avi and Rafael. I'm addressing the comments and will push new versions. Thing is that I rebased the Erator PR on top of Precious Master, resolving some naming conflicts. Third one is that I'm working on the exclusive log feature of RBD built on top. That will be built on top of the Watch Notify. That's me.
What is the essence of this law?
To prevent multiple RBD clients from using this conveying modifications to the same image.
There's a subsystem in Rados that allows the OSD to maintain some ephemeral. It's essentially an atomic message passing system for different clients using the same object. And RBD uses it as to create an exclusive lock messaging protocol so that different RBD clients can prove that they are the only accessor of a particular RBD volume. Because if they are, they can use an exclusive caching mode, right?
Okay.
The OSD side support requires some amount of ephemeral state and some amount of ability to say, I know which clients are connected to me on this object and are expecting notifies to be propagated to them. So there's some complexity associated with it, and there are Rados primitives for manipulating it. The relevant thing to grep for if you're looking for is watch notify. Capital WATCH and capital NOTIFY for the OSD op codes.
Okay, good, thanks.
I think that's a machinery RPG is using for implementing the transaction. And Ronan.
Okay, I'm finishing up the dotting the T's, dotting the I's, sorry, on the ASOC implementation. I'm mostly cleaning things up and fighting with destruction process sequences. What we talked about, the problem we have with SeaStor and this not playing well with, as it was phrased, with RAII in C++. So I have to do a few things around it. during processes termination. I hope to be able to finish this in the next few days because in the SeaStor Summit meetings, I was tasked with some development regarding the new SeaStor, and I want to start working on that soon. So this is my plan for the next 2 weeks.
Cool. Thanks, Ronan. And Sam?
Yeah, I've been fixing my object context branch. I believe I have it fixed now. It took me about a day to get a Docker container set up so that I could run CVD locally. And the bugs were in my own code. So I believe I have them fixed. I'm waiting to get the actual PR Jenkins thing to run so I can be sure of that, but I think I have it fixed now. That's it.
I recall you mentioned that you were looking at a HAN problem. Is that HAN exists in the vanilla master branch or in your own local branch?
It was my own code. At least I identified 2 hangs in my own code.
Okay, sure. Because we also have HAN in master
Well,
branch.
I was also hoping to find that one. That's the reason I took the time to set up the Docker container. I've got it running in a loop now, and I'm hoping I'll get it caught somewhere where I can look at the wreckage. We'll see.
Okay, sounds great. Thank you. Frida, anything to share with us?
No, I'm just attending out of interest because I had some work experience with the SSDs, writing SSD firmware. I just came across your document, Kifu, with respect to SeaStor, and I was just going through it, and I was talking to Josh as well, and he suggested I just kind of attend this meeting just to figure out what kind of work is being done, and if I have any scope of contributing in this space. So yeah, this is my first meeting that I'm attending. So I'm just trying to figure out if I can contribute in some way to SeaStor and Crimson.
Sure, thank you. Yingxin?
Yeah, last 2 weeks I managed to start Crimson Messenger with DBDK stack, a native stack, and I wrote a conclusion of what I found. So to be short, the first conclusion is that the native stack has better performance and has better scalability with more cores, but it seems to me by looking at its code, and there are still some caveats, including some missing features and some bugs in the native stack, and we need to address in order to be used with the Crimson OSD. So I think there are still some more features needs to be addressed, and I will try to look at how to do that. It seems that there are some major features are not supported, like to start multiple processes, multiple SeaStor apps with native stack, or to have multiple NIC devices, to manage multiple NIC devices with native stack, like that.
Okay, just to be clear, please go on, Ronan.
Sorry, continue. I will ask later.
Sure, thank you. My question is that the problem are in the SeaStor itself or in our code?
I think mostly from SeaStor native stack.
Okay.
Yeah, because if you start a SeaStor app with native stack, you must configure the device you need to be managed at user space, like to set up IP address. So currently, it only supports one device. And DPDK has two modes, the primary process mode and the secondary process mode. And it seems to me we can't start multiple a SeaStor app with native stack. It's because all the apps will start at primary process mode. Yeah, so there's only one primary process allowed in the same host.
Okay.
Yeah.
So, are you planning to do it by yourself, or can we ask the SeaStor community to support that?
I think that's the requirement is from ourselves. So I think the user cases is enough for ScyllaDB.
Why is
so
this?
maybe
Why is this? Don't they need to support more than one NIC? I understand the problem is actually supporting more than one NIC, right?
It's more that they
They're
don't
not-
seem to need native stack at all. I expect they're not going to be hostile to any fixes or improvements. It's just that they won't do them for us. Is that what you mean?
No, what I'm trying to ask is what I say. I read the document. I read the work you did. A lot of work there, and it seems that there is an opportunity there that is important to us. The performance and the scalability it's working versus POSIX stack, which seems to be really problematic when scaling the number of processors. So it is probably worth our time sometimes in the future. I'm not sure that now, but it's worth our time to invest in this. But the problems you mentioned seems to be things that ScyllaDB would want to solve. For example, using more than one NIC. Why isn't this?
Because they use POSIX stack. They use POSIX stack, which does support more than one NIC.
Yeah,
they're not bottlenecked by the messenger stack. They don't care. And using native stack is more complicated. So given that they aren't bottlenecked by the messenger code, they're going to use POSIX stack. That said, it's not like they'd be hostile to improvements. It's just that they probably won't do them for us, right?
Okay, I hope that they will fix their problems there and we will just use it. I don't think we have.
Support SeaStor at all. Let me put it this way: they don't support SeaStor. You can guide us to address the problem, but they don't support us in this way.
And that's reasonable, right? We don't have a problem with that. If we have an improvement we want to make that's good for us, that doesn't really matter to them. That seems like an us problem, right? Seems fair.
Yeah.
Yes, but I was hoping for them to count on them to invest.
I think we can count on them to improve things that directly improve matters for them.
Yeah, but they don't use native stack, so I also saw some stability issues, some bugs, some unhandled exceptions. Maybe it's because they just don't use it.
Okay, in short, it sounds that. Sorry, please continue.
What I'm saying is that it seems that it is not. We cannot count on native performance in reality. We will not be using a native stack in any near future. This I think is the bottom
unless
line.
we enable.
It depends on the scope of the improvements, right?
Yeah.
Remember, we have to rewrite the whole OSD. This may turn out to be small potatoes compared to everything else we have to do.
It seems that we cannot, at least I wouldn't broadcast performance measurements using a native stack with Crimson. I don't think it's relevant in any foreseeable future because we don't have the bandwidth to actually do the work.
Not entirely. What is interesting with placing Crimson and with putting Crimson on top of DPDK on top of the native stack is the fact that the interaction with network at the moment is the sole source of syscalls in Crimson. That's the reason why I'm extremely curious about performance numbers, about profiling basically Crimson combined with the native stack. At the moment, Crimson is achieving maybe IPC around 1.1. It's awfully similar to what we have with classical async messenger in Ceph. When you profile one of the messenger threads in classical OSD, you will see very, very similar IPC to what we have in Crimson right now. From 10,000 foot view, Crimson basically looks like async messenger combined with some very thin object store. So, if I'm just speculating, if we are bottlenecked mostly because side effects of syscall, then eradicating them, which is possible thankfully to the native stack, might change.
Oh, I agree. Radek, but another option is modifying the POSIX stack to do IOUing.
That's also one of the paths. The IOUing still would impose in this scenario when your process almost never ever does context switch, does mode switch. This would impose some communication between cores. What I mean is that IOUing is still much better than firing plenty of syscalls, but still native stack, still DPDK might be superior.
DPDK has more control of the device.
In other words, I'm less worried about the possibility that people will see these benchmarks and get the wrong idea than I am about making the right decisions going forward, right? So yeah. This represents an important data point, which we're going to use to make decisions. This is significantly faster with some numbers of cores, right? So eventually that's going to be the next place to find performance improvements.
Yeah.
I agree that we have to be strategic before then, but information is information.
Yeah, but I think we can say that this is not a low-hanging fruit.
Yeah, writing the OSD is a low-hanging fruit. We got to do that part first.
Okay.
So which is the low-hanging fruit?
Implementing the OSD. We have almost none of the OSD code written.
Okay, agree.
So if you don't have access to that doc, please send me email. I will add you, because the default setting doesn't allow to be shared publicly using.
Yeah, I know, it's super frustrating. For the record, I've been creating like GitHub RSTs for when I need to do just public sharing, but this works too.
Okay.
Yeah.
Mm-hmm.
Have you? What was the problems with Crimson OSD? Because what I'm seeing from the DO is that the testing was made on using the perf test of Messenger. So we have verified the performance of some subset of components we are kept at the moment in Crimson OSD. I would love to see entire process with native stack under testing. What was the problem there?
So currently Crimson OSD doesn't use two networks, right? It only has one. So the first problem is the one device problem. And the second is we can't start multiple processes in the same
Okay,
same
but
host.
one process testing with one NIC still seems to be affordable.
It's
Sorry?
also the case that it's designed that way, right? I thought that was a DPPK limitation. Only one process can have control over the actual PCI device.
But DBK has secondary process mode. It can like forward
Oh, I see.
some data to
Yeah,
secondary.
there is multi-process access.
Interesting.
And
Okay.
the third issue is we can't currently start the start messenger with more than one core. It will break because we have some hacks to move around the socket. And the current it doesn't work with native stack because native stack at lower level it remembers the core where it is created, so we can't move them like in POSIX stack.
Okay.
This is actually a messenger architecture problem.
Yep.
Yeah.
Okay, that's actually a good point. That's interesting.
And
But we could
talked
strip
about
those layers there. Yep.
Sorry.
But we could strip those things, right?
Actually, we won't. We'll go the other direction, right? We'll assign essentially an independent messenger for each core. That's the eventual goal. That's what we've been discussing.
That's the eventual. But right now, it's about legacy actually. The Crimson started from design assuming some kind of interconnector between cores. We started with the idea to shard messenger across multiple cores, which turned to be no-go. Then we moved to the one-to-one mapping, and in the future we will consider extending it to more cores at the price of making some modifications to the radius protocol to avoid the crossbar there.
I see, but even in that case, multiple cores would need access to the same NIC. I see what you mean. Okay, yeah, that's true.
Just one comment. The same future, I would say that the same future where we change the messenger is the future where we have a working native stack. So we don't have to support middle step without it.
No, that's true, but it's still nice learning what he learned, right?
And by the way, I added a comment, and I added a comment that one more thing that is missing, will be missing. SeaStor currently doesn't support work both, at least what I see, both native and POSIX stack together, and we would like to have the POSIX stack for this minor issue I'm working with, which is the ASOC, the admin socket.
Oh crap! Really? Oh, there's really no way to make that work with POSIX stack? No, there wouldn't be because it's an actual Unix domain socket.
Yes, and you can't.
Okay, what if we created, no, hang on a sec. What if we created a sidecar process that just shared a shared memory region with the Crimson process? The performance of the admin socket, the performance of the admin socket is not important. It's only used for control information between like debugging stuff, or no, that's not right.
Configuration also in the beginning.
Exactly. It's for introspection and configuration stuff. So can we just sidestep this whole stupid thing by just creating like a shared memory interlock and a sidecar process?
Yes, we can.
We should do that instead of screwing around with the POSIX stack. That's way easier.
Maybe, but I would say that there is more than one way we can think of designing around this issue. I don't think we should tackle this now, but yeah, there's more than one way to tackle this, but we should keep this in mind. This is a problem that should be handled.
Right, but I'm pointing out that it's kind of a unique one. I'm pointing out that this isn't general. Admin sockets look like networking because admin sockets look like, because Unix domain sockets are built on a networking sort of basic design principle. But there isn't anything else that works that way. It's just actual networking and Unix domain sockets. And Ceph doesn't use Unix domain sockets for anything else.
this was actually my question to you, because I don't know the rest of the system.
Yeah, there are no other users. It's just used for this. So this isn't a good reason to do anything to the networking stack. If we can just sidestep it, we definitely should.
We can, of course we can. No problem in that.
At least I think so. Is there anywhere else Unix domain sockets are used?
Do we really need Unix domain socket? Is the presence, is the usage of, is using the Unix domain socket for the sake of admin comments, is really the part of a protocol we cannot change? Maybe migrating.
Okay.
Maybe migrating it to TCP socket. Would be possible.
I wouldn't do this migration, because then you're getting into another problem of security.
Precisely.
The benefit of using Unix domain sockets for the this control plane is that you know that the origin is within the same host, and you don't care about security. And we don't want to have this. But we don't, like Sam said, we don't need to do it through networking. There are many ways to pass. Yeah, there are many ways to pass things around inside the Unix host. There are many communication protocols.
Yeah, sorry, I failed to totally understand what was going on with what you were working on. But yeah, if the only problem is just that native stack doesn't support Unix domain sockets because they're not a NIC, then the answer is to set up a second process to just shuffle the information over. That's way easier.
No problem. I won't do it now. I don't think it's worth our time now, because we're not we didn't yet solve the other problems with with native stack.
But probably you can note it down as a task in the project page, so we don't forget it at our discussion.
Yeah, so in the meantime, all we have to do is just make admin sockets work with POSIX stack, which should be easy.
Yeah.
Admin socket, I'm close to sending a PR for review for this.
Julio.
Great.
So if we want to move on with native stack, we need some development effort in SeaStor native stack, apparently.
I don't think it's a top priority.
But maybe just not priority. What is interesting, at least from my perspective, there is just how much performance we could get by moving to native, by moving to the PDK. That's the interesting point. So I would love to see really minimal, stupid, as dumb as possible configuration or /hack, just to get number, just to compare Crimson with even one process on one NIC with POSIX versus native. That's all.
Counterpoint. From that document, the one core performance is on par, and we already have a lot of things to test. So I think what we should take from this for now is that this is a fruitful place to look for IOP improvements in the future. But today, I think we should ignore it. I think we should just say, okay, we need work. Work will need to be done on native stack when we get to that point. But for today, we can rest easy knowing that there are IOPs there to find and focus on POSIX stack.
Okay, but the test is only about messenger. I bet it don't measure it lack impact of side effects of syscalls, which can be significant in Crimson. All testing here is just on top of the unit test.
Fair point. That could warrant further experimentation. I still kind of claim that we're most interested in experiments that change our decisions, right? So what would we do differently if we knew that native stack were 15% better than this document says it is?
Okay, not much. We could postpone.
It's because our next choices are real. Like the reason why it was really important to set up performance testing in the first place is that we're about to write a bunch of new code, right? So we need to know what the cost of that code is. But this doesn't really work like that. This is a fairly orthogonal set of choices to things we're doing right now that we can definitely make in the future just as easily as we can now.
Agreed, under the assumption that we want to do something that would kill this opportunity in the future.
Well, I would claim that that would be a mistake, so we don't want to do that.
Yep,
So
I agree.
we should notice if we do that and not do it. But I don't know that we need to spend a bunch of time building extra testing methodology to work that out. Like, we'll notice it pretty straightforwardly. We'd have to break the SeaStor interfaces, right?
Maybe.
I think. Like, what would we have to do to make native stack not usable?
Continue using more of the tricks of moving file descriptors around or whatever. This is
That's
the
a fair
only thing I
point.
can
So we
think of.
definitely don't want to use Unix IPC as such. But we probably weren't going to do that anyway.
Probably.
What we want to not use? Sorry, I wasn't able to hear.
Ceph doesn't really do this anyway, but hypothetically, we could introduce a bunch of additional processes and use file descriptor passing to pass, like, for instance, sockets between processes, right? And that would be an example of a thing that would be hard to make work with native stack, since it totally requires the kernel 100%. So let's not do that, I think is what I'm saying.
Yeah.
What I understood, what is the blocker of Crimson / native testing is just the legacy layer of SeaStor connection handling we have in Messenger. Is that correct?
Do you mean currently? Yeah, currently, yes. It's moving the sockets and some.
But not moving in the sense of STD move. There is SeaStor has abstraction of a socket that we a bit abused, to be honest, when we was trying to make the sharded messenger. My point is that we already, even abstracting from the native stack case at all, we should kill this legacy sooner or later. But if killing it would enable us to do the right testing with Crimson and native, I would opt for killing it now.
Sorry, killing what?
Okay. Yeah, killing what? Sorry.
The SeaStor : socket moving.
By moving it from one
socket
shard to another,
cross-ref and things like that.
Yeah, do you mean we don't need that right now?
Yes, we don't need it now, and moreover, we won't need it in the future. Because even to go with one-to-n mapping, we will still have one single messenger instance per core. We will never ever do any passing of sockets, connections, data.
We're not. That's what I was pointing out, Radek.
Yeah, but the problem is okay. So can we, if our OSD is started with multiple cores, can we limit the messenger to only one core?
We actually it's a choice we could make, but it's not one we would. What we would do instead is we would adapt SeaStor to be able to bind different cores to different sockets on the same TCP connection, which I think is possible in DPTK using the second process thing. It would require extensions to SeaStor's current implementation in such a way that one core passes connections to the other cores, but the other cores do the interpretation on their own.
But the one problem
In other
is,
words, it's a big pile of extra complexity that we'll handle in the future, I guess.
One question regarding this. Currently, SeaStor, there is the whole, if you look at the POSIX stack, there is the whole real stack compared with the AP stack, which runs on the rest of the process of the cores.
Yeah,
What we are saying is that, once I just complete the question, what we are saying is that we can just keep the issue of those, we will never really use the AP pseudo stacks.
In my understanding, if you do multi-core arrangements with POSIX stack in SeaStor, you will have one instance of IP and n instances of the second one. It's because SeaStor reserves the right to place the connection on a particular core for each. It's decision of a network stack. It doesn't up to you. Okay, there was a discussion with Avi on SeaStor Dev whether we can actually move connections between core, and the question was very simple: no, never ever. So even if we go, I believe we want to do to save some, to optimize the number of TCP connections in the system. If we go with the even if we go with the multiple cores per Crimson OSD, likely we will never do any movements between cores.
I wouldn't
we
go
could
that far, but under certain assumptions, I think that's true.
Yeah, but I need to understand how to limit the messenger to the single core in a multi-core SeaStor application. That's
idea was very simple. To designate, well, to handle multiple PGs on a core and enable the shard, this particular shard, with its own messenger instance. That way, you will never ever cross any core boundaries inside messenger.
Yeah, Radek, there's a problem with that though. That's easy with the kernel implementation because the kernel does that for you. But with DBDK, I don't actually know how you multiplex multiple cores onto the same NIC. Essentially, what you need to do is the NIC needs to be handling enough of the TCP stack that it schedules different interrupts on different cores based on the actual TCP session of the incoming packet. And I'm not totally sure it can do that. Do you see what I'm getting at? I think the conventional solution to this problem is one core acts as a sort of a gatekeeper and wakes up the other cores based on which one needs to deal with a particular session. And then those cores read directly out of the NIC or something like that. So a lot of details have to be worked out here. Suffice it to say that we will choose a design that minimizes core crosstalk while dealing with the realities of the hardware. Is that fair to say?
I'm not sure whether the NIC already does that for the. It might be that the NIC already does the core dispatching for us. I'm not 100% sure, but I think
it would have to, right? That's the only way that could. That's the only way that could work. We're talking about N cores listening on the same IP address, same NIC.
On the same IP address on the
just
same
on different ports. No, different ports.
Okay.
But nevertheless, the same physical hardware is getting the packets.
Yes.
So it needs to know enough about the sessions to dispatch it out to the appropriate cores, which I think it does. But the question is whether the question is whether DPDK knows enough about that to make it work. So there may be some work that has to be done there.
Yeah. Okay.
That's okay though. It's just that we will do what we need to do when we get to that point.
Yeah, it's not a task for now.
Yeah. Like it won't be different. It'll be more efficient, but similar to what the kernel is currently doing. Right?
Yep.
The kernel has a bunch of code for this.
I would argue that NIC has already some physical capabilities to give you what kernel does right now in using
It does,
using
but it's by the kernel drivers.
Yeah. Anyway, do we really need socket cross refs, foreign refs, all that stuff right now?
Or that thing
I
you were
don't think so.
describing, that thing you were describing, where different cores get their own messengers with different sockets, yes, that is a precondition.
Yeah.
Today, absolutely not. But I'm just pointing out that it is a precondition for making what you were describing work with DPDK. If that makes sense. In other words, it's a valid concern that we can worry about later.
And when we worry about it, we should discuss what hardware configurations we are going to support. For example, would we limit ourselves to supporting one NIC per core?
No.
And
No.
why not? Why not?
Short answer, because, well, okay, the new Xeon or the new Zen 2 cores coming out are 128 cores. Are we going to get a machine with 128 NICs? We are not. Yeah, so we have to assume that
I got it.
On one level or another, DPDK has to be capable of abstracting this part for us. But we will have to do some things to bend to the way its abstraction works, right? And that's a problem for tomorrow.
Yeah, probably vhost would help, but
okay.
But
we need to take care about it now.
Seriously, though, NICs do actually understand a certain amount of IP, and you are able to tell them what to do with packets when they come in. That's part of the whatever extended Berkeley packet filtering system that exists in the kernel. It's a real thing that has a real solution, but we will have to spend work on it.
So if I understand correctly, the next most valuable things to do is to look at whether we can confine the messenger into the one core in the multi-core SeaStor app, right?
I actually think the best thing to do now is to ignore native stack completely.
Okay.
And switch to working on SeaStor.
By the way, Sam, I think the machinery is by the way entirely the machinery we have right now. I mean the socket crossref, socket fref, all that stuff. It's for moving connections after they have been initiated, after they have been acquired by the user of Stack, and the dispatching we were talking earlier would happen much earlier, much before the application sees accept.
I know that, but with DPDK, the application for us, the process includes DPDK. Right?
Sorry, by application, I mean different point completely.
I follow you, but I'm saying that I'm seeing it as a sort of holistic thing. And one way or another, DPDK, the process, the thread, has to tell the NIC where to send the packets.
Yes, but we would expect that this handling will be actually put inside native stack.
Yes, precisely.
Okay, and I'm arguing that
but right now, native stack does not support that.
Yes, and
right. So we would have to implement that within native stack.
The thing we have in Crimson is for different reason, actually.
No. What I'm pointing out is that we would need that support in in native stack. That's it. I'm just pointing out that that support does not presently exist and would have to be added.
Agreed on that. What I'm saying is the current socket xref we have in Messenger of Crimson outside of natives, outside of the SeaStor stack implementation. It's legacy.
No,
That would be useful.
I get it. I'm just pointing out that in order to make any of this concept of like native stack dealing with multiple cores, that will require work in native stack. That's it.
Yeah.
Agreed.
For that
No
reason, I
disagreement
think
here.
we should put it off for now.
Okay.
I think we shouldn't bother work. I think Ronan is right. We shouldn't bother working with native stack at all right now. Like we have a big fat problem at us, which is a brand new disk backend that addresses a new set of devices that we don't actually have that much primary research for. I don't see any particular reason to chase a network problem that doesn't change choices we have to make, and we can definitely do this later. Like it's just not.
Apart from what would be important from the SeaStor perspective is just designing proper interfaces to avoid zero copy between
Radek, let's
DPDK
just
and
assume we're going to
SeaStor.
do that anyway. Okay.
Yep, we need to do that. All that could be important from the native is the ability to test that early. But maybe we could leave.
Why can't we test that with POSIX stack?
Because in POSIX stack you always have the DPDK, the mem copy in kernel. It's hidden. It's hidden from you.
I mean, that's true, but other than a blip in performance, would you really see it with DPDK either? Is it really that valuable?
Not for now. Not for now.
Yeah, I don't think it is.
It's not.
Like, this is important information because it does tell us where we can find some IOPS later, but we need to write SeaStor now. I think.
Agree.
Do we want to address what about SPDK? Do we want to address it sooner or later?
Sooner,
in the case
actually.
of SeaStor. If sooner, then actually having DPDK as soon as SPDK support in SeaStor might be useful.
How?
For testing.
I mean, so again, if it were free, I'd agree with you, but we need to implement a bunch of stuff in native stack.
And or maybe some legacy layers in current OSD. In Crimson. Of course, to have complex arrangements like spanning multiple cores, it might be hard. But if we consider only one Crimson process, one NIC, and one core inside one Crimson process, then it might be very easy to get there.
I don't see a reason to spend any effort in doing this now. We have a problem we should tackle first and have a working OSD. And everything else, I think, is not in the right direction to invest.
Well, the point is not to have just working on OSD. The point of the entire project is to have very performant OSD.
Again, it's just not clear to me that gives us information we actually can use. All it tells us is that it's faster to have DPDK, which we know.
Exactly, but we have absolutely no idea what's the amount of the gain will be there. If it's 15%,
right. So what is the difference between 20% and 30%? What would we do differently if it were 30?
Well, if it's only, let's say, if it's only 10%, then we should actually postpone not only DPK, but also SPDK in SeaStor.
But why wouldn't SPDK on its own give us that information?
Okay, if we could arrange some kind of good synthetic testing with only with SPDK, that's fine. The similar effects will play the role I would expect. I mean, no syscall on the hot path. If we could do that, then fine.
Well, for one thing, it actually seems easy to do that. You just write a local benchmark driver, right? That
Might be
doesn't
an
use the
option.
network.
Yep.
I don't know. Xingzhen, do you see this as an important strategic thing for Intel?
I think for Intel,
I mean,
DVD,
sorry, go ahead.
DVD is always an important project, and SPDK. So,
Well, I
we
mean,
are
if
very
Intel just wants to work on DBDK, that would be different.
as our team, we are very interested to see how DBDK will change the performance, and we want to enable DBDK with Crimson, but with the first place, we want Crimson to be successful. So, so maybe I will ask some directions from our team to see what to do next. Yeah,
I think collaborating on SeaStor is the way to go.
Yeah, I agree.
For one thing, you can still do SPDK there, right? Also,
that's a very good point. Yep.
We lack a huge we lack a huge amount of information about Optane.
Yeah.
I imagine you have access to testbeds.
Yeah, I have access. At least our team have some. Yeah, of course.
So of the two things, I think building a metadata structure that works well with Optane is probably more important than DBDK.
I agree.
Radek, does that seem reasonable, or?
I think, yeah, reasonable, I think.
Yeah, it makes sense having just SPDK in at the level of SeaStor seems reasonable, but it would on the side of network it would require some kind of maybe synthetic load generator to not involve kernel to avoid. What I'm pointing out is that even single syscall that a syscall has both direct and indirect costs.
Radek, how about creating a benchmark that simply drives the object store interface directly? No networking whatsoever.
Might work.
Can you think of a reason why that would give an incorrect output? Or why that would lead us astray, I guess.
I bet it might be worth doing. It can be an option, yeah.
Well, it's worth doing anyway, because that's the easiest way to get performance data out of a storage system, right?
Mm-hmm.
So I would argue we would do that either way. So
okay, I'm just thinking about. I'm just trying to compare in my mind. I'm trying to compare the effort of such kind of synthetic testing versus the native. With the native, well, we don't know whether the socket crossref is the only problem. If it is, okay, stripping it is extremely easy, but it might be also some other issues. There might be other issues there.
So I'm just pointing out that the reason I'm saying it's work isn't so much the features it doesn't have as the statement that it's not especially stable.
Might be, yeah.
So for that reason, doing benchmarking on something that isn't especially stable is like a big wad of extra work. Because you have to constantly second guess whether the numbers are valid. You have to fix test bed.
Yeah, back counting there could be expensive. Yeah, might be more reasonable to go with synthetic testing.
Yeah.
Yeah, valid point.
And it's not like we'll get only synthetic testing. We'll still get information with POSIX on SPDK. SPDK might be faster on its own.
To be honest,
I get that the behavior might be different from as if it had DPDK.
All I would argue in that scenario is that I wouldn't expect that if somebody wants to involve, if an user wants to invest in SPDK, he wants to go with POSIX stack. It's some kind of disjoint scenario, I believe. If somebody wants SPDK, he will also want to have SDPDK.
I hear you, but if it's still just faster, then that's useful information we'll have sooner rather than later.
Yep, but that way you will judge the scenario with not. All I'm saying is that you still have some syscalls and their indirect impact coming from messenger layer, potentially affecting the rest of the system. And it's extremely hard to actually sum up, to actually weight up all those costs. It's terrible, I believe.
Yeah, that's fair.
Have we concluded this meeting?
So any more questions?
SeaStor first? Sorry, SeaStor first?
Yeah, SeaStor
I'm
first,
sorry?
I think.
Yeah, I think that's the choice. Yeah. Or that's the conclusion.
So
Okay.
any further questions? Okay. Let's conclude this meeting. Have a good day and have a good night. Thank you, guys.
Thank you.
Thanks.
See you next
See you.
week.
Take care.
Bye.
Bye.
Bye-bye.